Assalamu alaikum. Ramzan Mubarak to everybody, and I hope that you are having a good Ramzan as well as good exams. So I was asked a few questions about short run production and stuff like that. So I'm going to explain a couple of concepts here. In this video, I'm explaining the Cobb-Douglas production function or the Cobb-Douglas equation. All right. So let's recall what we discussed in class. Okay, what is a function? When you say function, one thing is a function of something else. It means that one thing is dependent on something else. When you say it's a function, it means it is dependent on that something. All right. So here we are concerned with production function. So what is the production dependent on? The quantity that you produce, what is that dependent on? So we have a number of production functions. There is the short run production function is different. Why? Because in the short run you cannot alter capital, you cannot alter land. All you can alter is labor in the short run. So of course the short run production function will be very different from the long run production function. And even in the short run we have some special functions. So one of those production functions is called the Cobb-Douglas production function, and that is what I'm going to discuss now so that there is no confusion. Please remember, you only have to identify the factors that are included in the equation, and you have to explain them and the significance of those factors. So let's quickly look at the equation. The equation is Q is equal to AL to the power A, K to the power 1 minus A. All right. So that is the equation. I'm going to show it to you in a bit also. But right now, just note it's Q equals to AL to the power A, K to the power 1 minus A. Alright, so here we have the equation. Q is equal to AL to the power A, K to the power 1 minus A. Alright, so because this is the function, it means quantity Q is dependent on these factors. Now, on the exam, you just have to identify what these factors are. So let's look at them carefully. What is Q? The quantity that you produce, the physical quantity that you are producing, 100, 1000, whatever you are producing. What is this quantity dependent on? Okay, that's the big question here. What is this quantity dependent on? The quantity here is dependent on two things. Okay. One is L, which is labor. Obviously, in a firm, the number of units that you will produce will depend upon the number of laborers that you have. So, labor, that's the first thing. And K is the capital or the machines. So that's very common sense. Quantity that you produce will be equal to your resources, will be equal to, or it will depend upon, first and foremost, it will be a function of the labor, the level of labor, the amount of labor that you have, and the capital that you have invested. So that is, I believe there should be no problem in that. What is A? The capital A. Look at the capital A. The labor that you have, if you have a lot of labor, you have 10 laborers, you employ them, you hire them, you put them in their place, but they are not working, or they are working very slowly. So employing so many workers will not have any benefit for the firm. So that's where A comes in. What is A? A is the efficiency measure of that firm. Okay, how efficient the firm is at using labor and capital. The efficiency, it's sometimes called the efficiency parameter, it's sometimes called the efficiency measure, and it's a constant. The capital A and the small a, they are both constants. Okay, so if you have labor and capital and your efficiency is high, your quantity will also be high. If it's low, then your quantity produced will also be low. Alright, and then what is A? A is the share of labor in the total output. It's the share. Now this is the capital A is the efficiency of the firm overall. But once the quantity is produced, what is the share of the quantity? How much did labor contribute to that quantity? How much did capital contribute to that quantity? Supposing we manufacture 1000 units. What was the contribution of labor in that production of 1000 units? That is denoted by the power A, the small a. And what was the contribution of the capital? That is the power 1 minus A. Please also remember that the small a is always less than 1. So it's going to be 0.25, 0.75, something like that. Alright. Now, if the power is 0.75, if AL small a is 0.75, then what is the power of K going to be? 1 minus 0.75, which is going to be 0.25. Okay. So what does it mean? What does 1 minus A? Look at the power of K. What does 1 minus A mean? It means that the share of capital in the production is always less than the share of labor in the production. If you have produced 1000 units, then 75% of the work has been done by labor and 25% of the work has been done by the machines, because labor has to work the machines. The labor has to work itself, and how efficient the machine will also be dependent upon the efficiency of labor. So the share of labor, the small a, is always more than the share of capital in the production. That is why we always show the share of the power of K as 1 minus A. It's always less than A. That's it. That's all you have to know in this particular thing. This is something that shows the significance of labor. And here I have scrolled down. The entire slide is now right in front of you. This is what you have to learn. I'm sure you understand what this is. It's very, very simple. Quantity that you produce depends on labor and capital, and A is the efficiency of the firm, and the small a is the contribution of labor, and the beta, which is 1 minus A, is the contribution of capital. Okay, so that's it. Okay, thank you very much.